Okay, well, let's talk a little bit about confidentiality, integrity, and availability. When we talk about the three of these together, we'll use the term from time to time. CIA is how you might hear that term. Actually, in the CCNA Security Blueprint, they actually refer to this as CIA. So we want to just describe what confidentiality, integrity, and availability is. Let's start out by talking about confidentiality. A lot of times, the term that we hear here is encryption. And when we talk about encryption, what we're talking about is the ability to hide or privatize our data. Sometimes we'll use the term VPN here, virtual private network. And again, the idea is keeping this stuff private. Now, in terms of encryption, there are a number of algorithms that we use. When we get into cryptography concepts, we're going to talk about these algorithms and such. But what we might be benefiting from at this point is talking about them a little bit ahead of time. So we might have DES, which is Data Encryption Standard, which is a 56-bit encryption. We might have Triple DES, which is another encryption standard that we use, which is a 168-bit encryption. We have AES, the Advanced Encryption Standard. AES comes in a 128-bit, 192-bit, 256-bit encryption method. And so those are kind of the standard that we use today. So those are probably more appropriate these days than DES. DES is probably one that you're not really going to want to use these days simply because it's not very secure in terms of our capabilities today. So we use these encryption algorithms to hide our data. Now, when we do this, it involves the use of a key. Now, when we talk about keys, we first off have to understand that there's two different types of keys. We have a symmetric key and an asymmetric key. Now, the symmetric keys, we use the same key for encryption and decryption. Now, the algorithms that we see here, these are symmetric key algorithms. And we use these symmetric key algorithms for real-time exchange because it can happen very quickly. And so let's say we have a VPN tunnel, right? So we have a computer, and that computer is sitting behind our VPN gateway, which could be our Cisco ASA firewall. And then out to the internet, we have some type of connectivity there. Maybe there's another ASA on the other end, and we have a PC, or actually we have a server on that side. And we want to talk from the PC to the server. We're going to have the ASAs build this encryption for us. So they'll put up a tunnel between the two of them, and they will do a real-time encryption on our data. So as we send that data, it's going to be clear text. So we have clear data there. It's going to hit the ASA's interface. Once it hits the ASA's interface, we have encrypted data. That encrypted data is then sent real-time across the network. And then once you get to that ASA on the other side, the data is decrypted using that symmetric key, and then we have clear data again when we talk to that server. Now, this is what we typically use. Now, if we're talking in terms of these asymmetric algorithms, we would be talking about something like RSA, which is the Ravish, Shamir, and Adelman algorithm, the RSA algorithm. We use a public and private key pair in this case, public and private. And so it's important to understand the difference. The asymmetric algorithms are not necessarily a good algorithm to use for real-time encryption, but they are good to take some data, encrypt that data, and then later on maybe use it to decrypt. We can also use these RSA algorithms for authentication. So that's just kind of a high-level overview of confidentiality that we can provide using these different encryption algorithms. And we're going to go into more detail on these cryptography concepts when we get into that portion of the CCNA security. But for now, this is just meant to be a high-level overview of what confidentiality provides for us.